AMA for the DFO 0.5 challenges and development. This is a recording of the speech that we did the 20th of December 2020. And we are going to talk about the new challenges and the current development of the DFO 0.5 version. Brace yourselves because boring PowerPoint slides are coming. Who we are? We are Paolo Rollo and Francesco Cirulli, and we are also known as Orbulo and Frank. And we are two of the co-founders of Sidaro. The third guy, Matteo D'Andretta, is not here with us because he is not currently focused on this kind of development. And we are also known as the Grove Street team on the DFO development side. What we'll discuss about today? Today we'll talk about the integration of the latest Solidity development inside the DFO protocol contracts, the ETHITEM native integration inside the DFO, the new proposal operation and management, the multi-token voting system inside a proposal, and how we are going to pivot from the proxy to the double proxy contract in the architecture, and so on and so forth. Yeah, we must have so much to say. Our goals are to improve and to bring new features inside the DFO protocol by integrating the new functionalities in a perspective of an operating system on Ethereum. We also will bring gas consuming reduction on all the contracts and a byte-size optimization in order to reduce the amount of gas that we consume during the operations and during the deployment of a contract. Also, we are going to improve the code readability of the DFO protocol repository through contract comments and new documentation. This is the current state of the DFO protocol. This is the version 0.3. And as you can see, we have the main contracts, which are basically all the delegates of a DFO, and also some utilities like the voting token or the common utilities. Then we have all the interfaces contracts. Then we have the delegates, the well-known functionalities, and the functionalities contracts. An example of a well-known functionalities may be the check survey result, or the getbots RCAP, or the start proposal. So let's start from the first point of our speech, which is the integration of the latest Solidity development inside the DFO protocol contracts. The main feature here is the switch to Solidity version 0.5, and this means that we have the ABI encoder version 2 integrated by default in all our contracts. The ABI encoder version 2 is able to encode and decode arbitrarily nested arrays, structs, and dynamic variables, and this means that we can pass them into functions as arguments, or even use them as return values or inside events. This means that we can, for example, in the StateHolder contract, we can pass a struct while setting a new variable or while retrieving one. And this means that we will have a minor gas cost and a better code readability. An example is here on the new version of the StateHolder contract. As you can see, we have the struct var that contains all the data of a variable stored inside our StateHolder. And of course, inside the setVal method, which is the function inside the StateHolder contract, which sets a variable inside the state, as you can see, we take as an argument the element which is a a type var. Also, we brought inside the StateHolder contract some batch methods, such this allows us to set an input array of variables inside the state instead of setting them one by one. Also, this means that if we have more variables to set inside the StateHolder, we will pay less fees. And this is also true for the clear and batch clear methods, as before for the set val and batch set val. This is the same kind of function, but instead of setting a variable inside the state, this function removes the given one. The second point of our speech is the ETHITEM native integration. This means that in the DFO protocol version 0.5, the ETHITEM standard is natively integrated inside the protocol. Now, in fact, now the ETHITEM orchestrator is a new delegate. This means that it's passed during the initialization of a new DFO, and thus it's mandatory. And the new wallet of a DFO interacts with this ETHITEM orchestrator to wrap and unwrap in ETHITEM standard all the ERC 721 and the ERC 1155 that it receives. For example, if the wallet receives one ERC 721 token, the wallet will automatically wrap it as an ETHITEM. This is valid also for a batch of ERC 1155 tokens that will all be wrapped in the ETHITEM standard. This is the function inside the wallet that checks if the given address is already an item or not. This means that it must support given interface, and also while calling the main interface version, we must have a positive result. What we do before... I have an answer for that. Is this... Sorry, Siri. This is the hook that it's inside the wallet contract, which allows the contract to receive an ERC71 token. And this function, basically, every time the wallet contract receives a ERC71, if this is an old wallet of the DFO, the ERC71 is flashed to the new wallet. But if this is the current wallet of the DFO, the wallet checks if the token that it's incoming is already an ETHITEM, and also checks if the sender of this token is the orchestrator or not. If the token is not an item and it's not the operator that is sending it to us, we must send it to the operator to perform the wrapping mechanism. This is also true, as we said before, for the ERC 1155 tokens, single or batch. They all will be wrapped by the orchestrator delegate. And now I leave you to Francesco that will explain to you the new proposal, operation and management.
Thank you, Paolo. Thank you so much. So one of our main activities during this month of development concern the new proposal operation. So in the new version, the 0.5 version, we change a lot of things in the proposal operation. So in this slide we can see the current workflow, so the 0.3 scheme of a new proposal. So first of all, we have our user, that in this case is represented by Baby Goku. So the user call the DoubleProxy contract to create a new proposal. The proxy contract check through the MVD functionalities models manager if the new proposal concern a well-known functionality, and the models manager respond to the MVD proxy, so it gives back a result to the proxy. So this time the proxy can call the functionality proposal manager. The functionality proposal manager is a core contract in the new proposal workflow in the 0.3, because the functionality proposal manager create a new proposal, and a new proposal is represented by a new contract. So in the 0.3 version of the DFOhub protocol, every time we create a new proposal, we are creating a new proposal contract. So then this new proposal contract is passed to the MVD proxy that can store the proposal contract. This is the whole scheme, and this is the description of the workflow. So first of all, the user called the new proposal function in the MVD proxy. In this function, the new proposal, the user can set some fields that are mainly the code name and replaces. So, for example, if the code name is populated and the replaces is blank, we are adding a new functionality. While if the code name is blank and the replaces field is populated, we are removing an existing functionality. If the code name, if both code name and replaces fields are populated, we are replacing a functionality with a new one, so a new functionality. And in the last case, if both code name and replaces fields are blank, we are executing a one-time functionality. So in this case, the functionality is not stored is in the MVD FunctionalitiesManager contract as a regular functionality. So then, if the new proposal it's an emergency proposal, some voting token will be staked in the contract, in the MVD proxy contract, and then the contract will be given back. So the token will be given back to the user if the proposal passes. The point number 4 is what I said before. So the proxy called the functionality models manager, and this one check if the proposal involves a well-known functionality. So if there is a well-known functionality involved, the models manager checks if the functionality model is respected. Then the MVD proxy call the new proposal function on the proposal manager to store the proposal. So naturally, only the proxy can call this particular function. Then the last point, the MVD proxy contract receive back the created proposal. So next, yes, we have a few things here. So the MVD proxy called the set collateral data function and finalized the proposal creation. Then we have the whole new proposal hook functionality that is called by the MVD proxy if this is if it's present, and then the MVD proxy can start finally the proposal. So also this function is callable only by the MVD proxy. So this is the whole scheme, and the main problem in this workflow, so in the 0.3, is that we have a standalone contract, because as I said before, every time we are creating a new proposal, we are deploying a new contract. So from this point, a new proposal is a standalone contract callable by everyone to accept, refuse, or retire votes until its end or reachment of the votes are capped. So this stuff naturally is extremely gas consuming because of the new proposal contract creation every time that we are we are creating a new proposal. So in the 0.5 we change something, and in this slide we can see the breaking changes in the 0.5 version. So first of all, the functionality proposal contract is no more a standalone contract. So in the 0.5, if we try to create a new proposal, the new we don't have anymore a new proposal contract as a standalone contract. Then we have the new proposal contract, so the proposal.sol contract, that provides a struct. So this is new. So the proposal.sol contract provides the proposal struct, and then the proposal is managed through the proposal struct and integrated in the MVD functionality proposal manager. So we can see the scheme of the new proposal workflow in the 0.5. So first of all, we have our user, so Goku can call the MVD proxy. The proxy call the functionality models manager, so this is the same of the 0.3 because the models manager check if a well-known functionality is involved and the models manager responds. Then the MVD proxy call the functionality proposal manager. So from this point we have some changes because in the 0.5 the functionality proposal manager is very important because the functionality proposal manager create the new proposal using a struct, and then the proposal return to the MVD proxy that store the proposal. So we can see that the proposal is created and is managed through a proposal struct. So we don't have anymore a new contract, a new standalone contract deployed, but we have a new proposal struct created to represent the proposal. So we can see in this slide the proposal struct. So the proposal struct is contained in the proposal.sol contract, that is a new contract, and the struct, this struct, the proposal struct, contains all the fields, all the main fields to create a new proposal. So for example, we can see that we have the proposal ID, the proxy, the code name, the source location, etc., etc. And then we have also a field that is the get item proposal weight that we will see down. So the main benefits with the new workflow of the creation of a new proposal in the 0.5, the main benefit is a cheaper governance. So we reached cheaper governance because the gas consuming is radically reduced. So in the 0.3, to create a new proposal, we had to spend approximately 0.44 Ether with 120 Gwei. So with 1 ETH, not at 585, but at approximately $1,000. We can see that to create a new proposal, we had to spend a lot of money. But in the 0.5 we have to spend only 0.1 from 0.1 to 0.2 Ether with 120 ways, so is radically reduced. Yeah, this is a little meme. So other benefits in the 0.5 are now we have a more flexible and refreshed way of proposal management, because we can use some new feature. So some new feature, for example, the proposal struct that is managed thanks to the Solidity 0.8 version. We have a simplified operation management using a single contract, because as I said before, the functionality proposal manager contract in the 0.5 is very important, because it's the contract that manages all the new proposal workflow. And then the last point, we deleted some redundant code. So another important point, and personally this is my favorite point, is the multi-token voting system. This is really cool, because we can see that in the 0.3 we have only one voting token that is represented by an ERC20 token for each DFO. So we can vote only using the voting token of that specific DFO. So it means that, for example, if we consider the DFOhub DFO, we can vote only using the voting token that in this case is Beadle, for example, that is an ERC20 token. So the voting system created through the smart contract protocol support only ERC20 token standard methods. And then the last point, last but not least, votes expressed through that specific voting token have always the same weight or power inside the proposal. So one Beadle, so one vote with one Beadle counts as one vote, because all votes have always the same weight. In the 0.5, we have a lot of changes, very important. First of all, the ETHIO integrates natively the ETHITEM standard. So this means that we don't have anymore only the ERC20, but we integrate and we support the ETHITEM standard in the DFO protocol. Then we have multiple collection in item standard naturally. So this means that each ECO has n different potential collections supported or accepted. So if in the 0.3 we can vote only using that specific token of that specific DFO, in the 0.5 we can vote in the ECO with token that are item from different collection that are supported by that specific ECO. So every ECO can support a different collection of item. So the votes are allowed using items from different collections, as I said before, supported by that ECO. In an ECO, both wrapped items, so all existing, for example, ERC20 or ERC1155, or native items can be part of the voting token. So we can use wrapped item or a brand new collection, so a brand new native item created. And the last point that we can see in the slide is that the voting system support ERC1155 methods and no more ERC20, because we support the item standard. So this is very important because we can use the batch transfer method of the ERC1155 with items of different collection in only one transaction. So then the last point, but probably the most important, is that voting tokens may have different weight or power inside the ECO proposal. So it means that the item weight or the item power of that specific item from a specific collection supported is defined by a new mandatory functionality added to the ECO. So this is a functionality, the get item proposal weight functionality, that all the ECO must have. The get item proposal weight functionality, we can see here some part of the smart contract of the new functionality. So we have here the classic on start on stop method, and then we have the get item proposal weight. This function is very important because we pass as input an address of the collection address and the object ID, and the function returns the weight of that specific item inside the ECO, so inside the voting system, basically. So this is the on ERC1155 batch received classic B method that we have in the MVD functionality proposal, and this is a classic method, but we had some extra feature. So for example, we can see that the get item proposal weight functionality is called by this function, and the get item proposal weight functionality return the weight of that specific item. So then votes are calculated using their particular weight. Then we have the function called a new function that is the on token received, that we can see here. This function is also very important because this is the function that counts the accept, the total accept, and the total refuse votes. So weighted with the specific power. So then one last thing on the voting system is that with the new voting system is very flexible, and every ECO can adapt, can tailor and personalize the voting system with adding and specifying all this kind of feature. Paolo, you are mute.
Finally, we will be discussing the pivoting from the proxy to the double proxy contract, and what we mean by pivoting. And before explaining what we mean by pivoting, we need to explain what's the role of the proxy in the version 0.3. In the 0.3, the users can directly interact with the proxy, and this means that the proxy is one of the main interfaces of the DFO. The proxy in the 0.3 also keeps track of the latest correct versions of all the microservices that effectively compose a DFO. It can start a new proposal, it manages the wallet, etc., etc. And it has a really heavyweight structure, and it's quite difficult to change proxy. The double proxy instead, in the version 0.3, is the easiest way for side or external contracts to locate and query the DFO. So directly link the proposal to external contracts may become a problem. And in order to avoid this, it's better to link external contracts with the double proxy. So the name speaks for itself. The double proxy is basically the proxy of the proxy. It can also be updated by proposal, and it's a delegate that, as we said before, keeps track of the most recent proxy address and all the previous versions. It is very lightweight, and it has a very simple structure and logic. What we mean by pivoting is changing those kind of roles, but in a different way. Our main goal is to allow for an easier proxy upgradability. In fact, now if you want to upgrade the proxy contract, you must pass to the new one all the ECO delegates. In the new logic, all the delegates are inside the double proxy, meaning that you can simply update the proxy without worries. And this kind of helps us because the double proxy has a cheaper and less complex logic compared with the proxy. And this means that it's much more difficult. There are kind of less reasons to update a double proxy rather than the proxy. But this does not mean that the proxy won't be the core of the protocol anymore. It will still be called by functionalities, but as before, the external contracts will interact with the ECO double proxy. So the double proxy gets shifted at the top of the architecture pyramid, but at the center of it, there will always be the proxy. This is an example of the double proxy contract that now supports the delegates and inside its state. And when you initialize the double proxy contract, you pass all the delegates, such as the functionality proposal manager or the StateHolder or the ETHITEM orchestrator, as we said before. And also the setDelegate function and all the methods that manage the delegates are inside the double proxy, such as the setDelegate or the addDelegate function. So we wanted to explain how this kind of interaction works out. And here we have the Dragon Ball Z characters, and we have the Son Goku and the Dragon Balls, which are basically the proxy and the delegates, and Vegeta is the double proxy. As we said before, Vegeta keeps track of all the proxies that we had in the past and the current one, and manages all the functionalities inside its state. an external user will interact with the double proxy, sometimes not directly, but the DAP will for sure do, to request what's the latest version of the proxy. The double proxy responds with the current proxy contract, and so now the user can interact with the proxy, maybe asking for a functionality execution. The proxy will ask the double proxy the given functionality, for example, the FunctionalitiesManager. The double proxy will respond with the latest FunctionalitiesManager address or the given delegate, and then the proxy simply interacts with the delegate. The delegate will return its response value that will be prompted to the user later. Also, we have the external contracts or side contracts. Here we have Freeza or Cell, and they, like the external user, they interact with the double proxy of the DFO that returns the proxy address, the latest proxy address, and also then, of course, interact directly with the core of the pyramid, which is the proxy. Thank you for listening to our AMA, and I hope that you understood everything. And if you have any questions, please leave them in the comments or on the Discord channel. Thank you very much.
Thank you so much.